Hello everyone. In this video, we are going to discuss about the Smith chart and the properties of Smith chart. So your Smith chart is defined as Smith chart is a special polar diagram containing constant resistance circle Ra and constant reactance circle Xa and circles of standing wave ratio and radius lines representing line angle locus used for solving transmission lines and waveguide problems. So we can determine the voltage standing wave ratio using the Smith chart, and also we have constant resistance circle as well as the reactance circle in the Smith chart. Using this constant resistance circle and reactance circle, we can plot the load impedance or its load admittance using Smith chart. And coming to the properties of Smith chart, the first property is it consists of constant resistance circle and constant reactance circle superposition on one chart. So this circle determines the constant Ra circle, that is your constant resistance circle. So it starts from 0 to infinity. So your Ra is plot on the real axis. So this line is nothing but your real axis. It is starting from 0 to infinity. And this circle represents the constant resistance circle. It starts from 0, 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5 and up to 1. When your Ra is equal to 1, this circle denotes the unit circle and it goes on till infinity. The next point is the value of Ra and Xa are normalized. In order to find the normalized load impedance, so we have to use Zr is equal to the normalized load impedance is given by Zr. Z small r is given by Zr divided by the characteristics impedance Z0. So if you find Zr by Z0, you will get the normalized load impedance. So if you get the normalized load impedance, you will get the normalized Ra and Xa. And then we can plot Ra and Xa in the Smith chart. That is the next step. Now, the horizontal line passing through the center of the Smith chart represents real axis. So this is your real axis. So this is the horizontal line which is passing the Smith chart. This represents the real axis. If Xa is greater than 0, inductive reactance lies above the real axis. If Xa is greater than 0, so the reactance line is this one, this line. So if Xa is greater than 0, it represents the inductive reactance and it should be above the real axis. It should lie above the real axis. If Xa is less than 0, it is a capacitive reactance and it should lie below the real axis. So this is the real axis. So if Xa is less than 0, it should lie below the real axis. If Xa is greater than 0, then it should lie above the real axis. And if it is greater than 0, it is nothing but your inductive reactance. And if it is less than 0, it is nothing but your capacitive reactance, that is the negative one. If Xa is equal to 0, it becomes the real axis. That means if Xa is equal to 0, we will be having only the resistance. That means if the Ra is equal to 1 and Xa is equal to 0 point, that means what? The reactance is 0 and the resistance as 1. It represents the unit circle. Okay, so that means this point. Here, Ra is equal to 1 at this point, Ra is equal to 1 and Xa is equal to 0. So this circle denotes the unit circle. So Ra is equal to 1 and Xa is equal to 0 point is the origin point. It is also called as the origin point of the graph, and corresponding Ra is equal to 1 circle is called as unit circle. So the extreme left of Smith chart along the real axis, both Ra and Xa are 0 indicates 0 impedance and short circuited connection. So the extreme left of the Smith chart. So the extreme left of the Smith chart denotes a short-circuited line. Here Ra is equal to 0 as well as Xa is equal to 0. Similarly, in the right-hand side, the extreme right of the Smith chart along real axis, Ra is nothing but infinity and Xa is equal to infinity, indicates infinite impedance or open circuited connection. So the extreme right side of your Smith chart. So here Ra is equal to infinity as well as Xa is equal to infinity. Both your resistance and reactance is infinity. So it has infinite impedance as well as it is open circuited end. And this end is nothing but the short circuited end. So on the periphery of the Smith chart, 3 scales are provided. So the periphery, on this periphery of the Smith chart, so we have 3 scales. So this is your first circle, and then this is your second circle, and then we have 3 circles. So the outermost scale, the outer circle, so in the clockwise movement is used to calculate the distance of the stub from load towards generator. So the outermost scale represents what? In the clockwise direction. That means you have to move in the clockwise movement. So it is used to calculate the distance of the stub from load to the generator. And the next scale, that is your next circle, it is in the anti-clockwise movement and it is used to calculate the distance of the stub from generator towards load. So the outermost scale represents the distance of the stub from load towards generator, and the second scale represents the distance of the stub from generator towards load. Now coming to the innermost scale, that is very important. So the innermost scale is used to determine the angle of the reflection coefficient. So here you will be having the angle of the reflection coefficient, that is your innermost scale. So this is nothing but your periphery of the Smith chart. So next video we'll discuss about the problems related to Smith chart.